We are live. This is the live broadcast of the This Week in Science podcast. And this week it is a solo show, not a sold out show. It would be nice to have a sold out show. You would make my TWIS solo show sold out, my Dr. Kiki's Science Hour of science fun. Oh, yes, the One Mic Show. Who am I talking to? I'm talking to you, everybody. And thank you for joining me. There may be edits. This may be a shorter show than normal. Maybe not the full 90 minutes, even that we try to reach every single week. But I am so glad to have you all here with me to talk about science this week. So, without any further ado, let me not change my camera or do anything because it's time to start the show. Oh my goodness. In a 3, 2, this is TWIS. This Week in Science, episode number. Let me get back to that again. What number is this? It's so many. I don't even remember anymore. We're going to start over again. Okay. In 3, 2, this is TWIS. This Week in Science, episode number 861, recorded on Wednesday, February 2nd, 2022. Why is 1 the loneliest number? Hey everyone, I'm Dr. Kiki, and tonight on the show, I will fill your head with Trojans, guts, and T cells. But first, disclaimer. Like the ever-changing surface of the sea, so goes human history. It's strange, we search for stability when what is optimal is always shifting. The wind blows and creates ripples across the sands of time, yet humans search for a cave where they will be protected from the elements, where their dancing shadows will be forever etched against the walls. We ache for safety, security, certainty. And This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I wanna learn everything. I wanna fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I wanna know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you. Welcome, everyone, to another episode of This Week in Science. And yes, you may have noticed that it's only my voice so far. I'm Dr. Kiki, and tonight I am the only host of this show. Justin is taking care of a sleepless baby, and Blair is really not feeling well. So, unfortunately, it was a last minute maneuver, and I have no co-hosts, but I'm here because we always try and bring you This Week in Science when we have said that we're going to bring you This Week in Science. So thank you so much for joining us for another week of science, discovery, curiosity, a little bit of uncertainty, I hope, and we will dig in to the science together. On this week's show, I have science news. I've brought you stories about Trojan asteroids, a stronger plastic, capybara guts, alcoholic monkeys, and our weird vision. Yes, we have not weird visions, but we have weird vision. Yes, our eyes and our brains and the way they work is very odd, and we will get to that toward the end of the show. As we jump in tonight, I do want to remind you that if you have not yet subscribed to This Week in Science, you can do so. Look for TWIS or This Week in Science on your favorite podcast platform. We also stream weekly and are available on YouTube, Facebook, and Twitch. You can find us as TWIS Science, TWISCIENCE, on Twitch, Twitter, and Instagram. But if all these things are hard to remember, just go to twis.org. That's our website for more information. Wow, it really seems like the front part of the show goes so much faster when I'm not talking to anybody else. It's just me and you, everyone. Are you ready? Are you ready for all of the science news? Okay, let's jump in to the stories that I brought this week. This week we have news of a second Trojan asteroid sharing Earth's orbit. That's right. There are Trojan asteroids around many planets in our solar system, and we've even sent Lucy, a craft or it's a mission that will be investigating the Trojan asteroids, Trojan moons around Jupiter. And we have our own, which is pretty cool. This particular space rock exists at the L5 Lagrange point. It's one of those kind of weird gravitational dwell points where everything's kind of balanced out and there's not as much push or pull going on. And so within this L5 region, there is 2020 XL5, and 2020 XL5 is about 1.5 kilometers wide. It's over 1 kilometer wide, and they've just reported, researchers out of the University of Barcelona and their colleagues, which is an international team, but the observations were made from an Earth-based telescope that is located down. They've used several Earth-based telescopes actually in order to make the observations of this Earth Trojan, published their confirmation in Nature Communications. It's pretty exciting because it when you think of what a planet is, you think of a planet as having completely cleared its orbit, and now we have the moon, which is right near us, and we can see it, and it shares the orbit with it. It is tracking with us. It's the moon is trapped in our gravity and is basically, even though it wants to pull away, it's inching away, and we will eventually lose the moon someday. Not anytime soon, though. So if you have youngsters who are listening, and you can ensure them that there's no problems with the moon. They'll be able to look up and see the moon for, you know, hundreds, thousands of years to come. And we take that for granted, and then we consider there are asteroids, but we never really think, oh, we've got other bodies sharing our orbit. And so these Trojan asteroids, the first one having been discovered back in 2010 in the L4 Lagrange point, and it's just very exciting to know that we're not alone in our rockiness in our orbit. This particular rock, 2020, what is it? What did I call it? 2020 XL5. It sounds like a car, like it's going to be some kind of a model of a BMW or something. This 2020 XL5, it is going to be perturbed by other gravitational forces and eventually make its way out of our orbit in about 4,000 years. So perhaps we will be seeing it someday. And I did want to bring another space story, just super quick, because this is kind of my trying to keep track of all those predictions that we made at the beginning of the year in our prediction show. I said that the SLS and the Artemis mission might not make it this year. Well, Artemis has officially been postponed again. They haven't given it a launch date. They say they're looking at dates for April or May, March or April, May time to look at launching Artemis 1, which relies on the SLS, which isn't going to be tested until March itself. So the fact that they have pushed it back, haven't given it a particular launch date, I think they're giving themselves wiggle room to continue to push that mission back. We'll see. Will the massive SLS, that space launch vehicle, actually get things into space? Will we go to the moon? Will NASA take us there? Yeah, we still have to find all that out, but I don't know. So far, my prediction, I think, is it's staying on track. So we're gonna keep track. I will keep track of that. You can maybe help me keep track of it during the year. John Hogan, I too would like to see a launch in person. I have never seen a space launch in person. The timing and the locations and distance from where I've been have never made it very easy, but it yeah, with the number of space launches that we have now with regularity, and those numbers are increasing now that the private commercial space industry has ramped up. I think we're going to see many more launches, and all of us will have more opportunities to get ourselves, maybe, perhaps, more opportunities to see some of these massive the massive proof of our human technological ability. Welcome, everybody. Okay, let's keep moving forward in the science. Beyond our Trojan asteroids, beyond the uncrewed Artemis mission, let's talk about fake photosynthesis. Well, not really fake photosynthesis. It's artificial leaves. That's what we want to talk about. We want to talk about carbon capture using artificial leaves. Researchers have developed a system in which they have basically created, they're using wet and dry chambers, and they're using oxygen and hydrocarbons and pH to enable the transfer of or the isolation of carbon dioxide out of regular air. So this could be the kind of thing that would be used in flue gases in industry, or it could potentially be used just I'm imagining this as something that would be maybe a small size that you could have in your home to capture carbon dioxide from your own home, maybe powered by solar cells. So you have solar power powering this new artificial leaf system, which is very modular. They say it's about the size of a backpack. And you could isolate carbon dioxide from the atmosphere within your home. And it could be tapped into a seltzer fountain in your kitchen or in your in your wet bar. Yeah, I know. I have ideas and thoughts about very silly things sometimes. But these UIC College of Engineering scientists, they've pretty much distilled down this new method that allows the cost of carbon capture to be significantly decreased. The materials they're using, which is a very basic electrochemical membrane that allows the transfer of the molecules to get across from the dry side to the wet side across the electrodes, um, allows the concentration of carbon dioxide to happen in such a way and in such efficiency that they're estimating it would be about $145 per ton of carbon dioxide, which at this point is about, for most carbon capture technologies, they're looking at about $600. And they say to be competitive and to really make this kind of technology, carbon capture technology, start to work, ideally, we would be getting down under $200. That's what the United States government wants us to get, but to really work on our atmosphere and drawing down carbon, we need to get to a price point of about 50 to $60 per metric ton of carbon dioxide being removed from the air. But this is a very simple solution, and they say it only, for their backpack-sized module, it uses about the same amount of electricity as a light bulb. So it's not incredibly energy intensive either. It just needs a bit of electrical charge to charge the membrane that's in the middle of the unit. So anyway, yeah, carbon capture. Basically, I mean, I'm really imagining these things. Perhaps maybe not on every house, but this could be the kind of setup that would be on hotels, or maybe you put them in hospitals, or, yes, in the flues, in industrial applications where they capture those mixed gases that are coming out, but are able to isolate the carbon dioxide, and which is such one of the big problems. That isolation is actually being able to do efficient isolation in an easy, price effective way. This is what we're looking for, and this seems like a really great solution. So we will see where it will go. And no, JG, I am not telling you that you can turn wine into champagne, but you can turn wine into champagne if you have, if you had carbon dioxide seltzer machine in your house. White wine. I wouldn't recommend doing that with red wine. It might not taste as good. But yes, I've actually done that with a nice bottle of rosé. Yeah. When lacking your rosé bubbly, go straight to your soda fountain. All right, let's move forward from this one bit of technology to another fun piece of technology that I thought was kind of neat this week. Researchers at MIT have developed a new, thin, strong plastic polymer. Yeah. We need more plastic. Like, I need a hole in my head, kind of. It might be the thought that's coming into your head at this moment in time. But this new polymer is made from monomers, single units of melamine, and you might know melamine from those acrylic plates. There are lots of little lots of the hard acrylic dinnerware or cookware is melamine. And yes, it can be toxic if it is not treated correctly, but MIT chemical engineers have devised a way to get, instead of polymers, to create long string-like polymers, which is what normally happens. You have monomers and they attach like a chain and they create like a long string of spaghetti polymer, and you kind of mush all those things together and the polymers can create all sorts of different forms. But they have not yet been able to create single sheets. A two-dimensional sheet that's lightweight and strong has been something that chemical engineers have been trying to develop for a very long time. What ends up happening in most cases is that they start to grow the little sheet, but then a little monomer pops up in one direction or another, and then it blurbles out in the wrong direction, destroying the integrity of a single two-dimensional sheet of polymer. So now they have devised this way. They've published in Nature this week their methodology for creating this melamine two-dimensional flat polymer sheet, which they say is as strong as steel, but incredibly lightweight. So this could create new coatings for automobiles. This could create new shells for computers. It could, the applications for this kind of a moldable polymer that's very strong, and as long as it's not brittle like steel can be in some cases, it can be incredibly useful. So they've got these sheets, but once again, melamine, it's toxic. So are we just adding more toxic stuff to the environment if you can't figure out what another thing? And plastic, do we really need more plastic? Can we start figuring out other things that are more sustainable yet? I mean, it's not the 60s anymore, anyone. Well, two-dimensional, JG, and when I say two-dimensional, I mean in a very flat sense where it's got an X and a Y axis, as opposed to XYZ axes where you would think of it being more of a cube or a sphere. This is a single molecular layer that can spread out and be like a flat sheet of paper, which, yes, if you're really cutting hairs, that fine, splitting hairs, it is three-dimensional, but yes. Yes, I will agree with you on that one. Moving on from melamine polymers, let's talk about microbes. Who out there loves microbes? Have we learned to love microbes yet? I do love microbes. We don't think of them as our friends all the time, but indeed they are. And they're everywhere in this world. Some researchers just published their work looking into the microbial world to look for a particular JG. Yes, both love and hate. Love and hate microbes. Yes, Ashley. You love some of them, not all of them, but yes. We don't like the little viruses that make us sick, but we love the phages that like to attack the bacteria that make us sick. There's so many that we love. We love the bacteria that are in our yogurts, that are in our pickles, the things that give us the good food. No, let's not be mad at microbes. Let's look at them as the wonderful wild world that they are. Anyway, these researchers were looking for a particular capability that they found in a certain strain of bacteria that had been easily grown in their laboratory that they had been looking at for a really long time. And these bacteria that they had discovered were able to, and this is a quote unquote, breathe rocks. And so what I mean by breathe rocks? Well, the microbes can establish an electrical connection. So they use what they call EET. This is not ET, it's EET, extracellular electron transfer. So across their cellular membrane, the bacteria are able to transfer electrons. And usually this has something to do with, say, a proton pump or some kind of pore in the membrane that allows things to pass one direction or another. And so there's a trade-off of energy. And electrons in this breathing, this respiration, they bring in electrons, which power their metabolism. And so initially they were just like, wow, we've got these bacteria, Shawonella onidensis. Woo, one of the first EET capable organisms. They looked at it in the lab, they had it in the lab for a long time, and they were like, "Oh, nobody else is gonna have this skill. This is super special, this EET-ness." Well, they did, as scientists do, they had to delve in to the microbial world and really take a look around. And, oh, yeah, it's everywhere, and in fact, microbes are sharing it with each other through horizontal gene transfer, which is the trading of genes back and forth that has nothing to do with reproduction. They just go, it's like playing cards, and they're like, "Go fish. Oh, okay, I'd like to take that one out of your pile." And these genes get swapped between different bacterial species. And so they've found that across the bacterial environments, different bacterial species are capable of extracellular electron transfer, EET, this breathing of material in the environment. And what they believe is that the the bacteria, as they gain these genes, they probably make adaptations so that they can specifically use EET in whichever environment they're in to take advantage of the resources that exist where they are so that they can live in the most efficient, effective way possible, which is what we all want to do, right? I'm going to take advantage of what I've got here. Ooh, I've got a new tool in my tool chest. Oh, yeah. But I can adapt it a little bit and make it work. Yeah. So the thing that comes from this, though, is when you think of the bacterial world and how bacteria have existed for millennia longer than other life forms, the more complex, quote unquote, complex life forms, such as humans, mammals, etc. Microbes have covered the earth, and we think of ourselves as amazing architects, but bacteria have formed the earth as much, even more so than we have. Bacteria have led to the oxygen that we breathe. Bacteria have altered the surfaces of the planet throughout its evolution as long as life has been living. So our planet is a form and function of the life that is on it, which is really very, very cool. Okay, no more microbes. Are you ready for capybaras, the world's largest rodent? We love capybaras, don't we? Capybaras are so cute and they're just these gentle, grass-eating rodents that are massive. Seriously, capybaras. Some people have capybaras as pets. Other people think capybaras could be raised and used as a food source. I'm not of the eating capybara persuasion, but capybaras. How do they eat? How do they digest what they digest? Well, of course, researchers have been fascinated by the way that capybaras digest their food. And oh, how do they do it? With the help of microbes, just like us. That's right. Oh, the microbes. The microbes give the capybaras the ability to digest the grasses that they eat. And so when we think about grass eating organisms, normally we'll think about cows or deer, the foregut fermenters. Maybe they have multiple stomachs, maybe they have multiple chambers, maybe they digest early in the intestinal area region. Um, Foregut fermenters are one kind of grass eater. They have bacteria that allow them to break down the cellulose and the lignin and all of the food that they're eating. Capybaras, being rodents, they do it differently. And so they are what are called hindgut fermenters. That's right. They ferment in their cecum. That's their large intestine. So capybaras, nice big rodents, they've got a bunch of gas in their guts. And it's all because of the microbes that live there. And according to this new study that is out in Nature Communications, I think this week. Yeah, Nature Communications. Uh, they're saying their title is Gut Microbiome of the Largest Living Rodent Harbors Unprecedented Enzymatic Systems to Degrade Plant Polysaccharides. And I just wanted to share with you a quote that I pulled from the paper because the author of this paper is a brilliant wordsmith. Yes, the science gets across and it's done very well, but the words and the way they're melded together, they're poetry. So let me just read this to you here. These findings highlight the potential of the capybara gut microbiome as a reservoir of uncharted enzymatic systems for carbohydrate processing, and thereby expanding our current understanding of gut microbial strategies from hindgut fermenters to overcome the plant cell wall recalcitrance, which might be instrumental to foster the development of value added products from lignocellulosic agro-industrial materials. I honestly love scientific writing when it's done so well using the exact words that are necessary to explain. So, what is this saying? In the gut of the capybara, they have found microbes that have really cool enzymes that they haven't really considered before, which could potentially be used to help maybe with biogas development or other materials that come from industrial breakdown of plant material. So from the capybara gut to the future of our sustainable energy program, perhaps. I love capybaras. Fada, what have you done there? It's not capybara, it's a kookaburra, but I do appreciate it. Capybara sits in the old gum tree. Merry, merry king of the bushes, he laugh. Capybara, let dance. Capybara, gay your life must be. But it's a kookaburra. The capybara would just be sitting there chewing the grass because they're so mellow and they just want to chew the grass. Oh, these little capybaras. So this was my ode to Blair's Animal Corner, talking about the guts of the capybaras. Does it take guts? Do I need to show you a picture of a capybara? I should have shown you a picture of a capybara. These cute little capybaras. These wonderful capybaras with their serious faces. Yes, their serious faces. They look like giant guinea pigs. and they're very friendly, and maybe I will move to Brazil and start a capybara farm. That might be a nice way to go into my old age happily with a capybara farm. Enzymes from the capybara gut. Oh my goodness. Thank you for joining me for this episode of This Week in Science. I'm so glad to be here talking with you about science, and I'm glad that you decided to spend this hour with me. If you enjoy it, please share it with a friend. Okay, let's move on from capybaras to COVID. Whoa, what a transition. Okay, so most everyone is aware of Omicron, the latest variant of COVID-19, SARS-CoV-2 virus at this point in time. Omicron has surprised scientists by having a related sister called BA.2. The original Omicron strand is called BA.1. Some researchers think, however, that the BA.2 strand shouldn't necessarily be considered exactly the same as Omicron because they found that they have differences. One of the interesting differences that is concerning is the fact that BA.2 is more transmissible than BA.1. So BA.2 has been spreading rapidly in areas and possibly gaining dominance against Omicron. Now, the original Omicron BA.1 has a lot of mutations that have allowed it to escape from vaccine coverage. So the vaccine efficacy has decreased. 3 doses of the mRNA vaccines have been recommended to this point in time to enable the antibodies that normally battle in your primary immune system response to be able to fight off the infection. Well, BA.1 kind of gets around that a little bit, so we have a lot more breakthrough infections of BA.1. BA.2, however, is a little bit more similar to the original Delta strain. So a lot of the mutations that are there in BA.1 that allow it to escape vaccines are not there in BA.2. So BA.2 gets hit by those antibodies a lot harder. So even though it's more transmissible, it is getting captured and controlled by vaccines a lot more easily. So what this means is more unvaccinated people are getting the BA.2 strain and spreading it to each other, whereas people who are vaccinated are more likely to be getting sick with the BA.1 version. So, all that said, antibodies are very important. BA.1 is battling those antibodies and trying to avoid them. BA.2, less able to avoid the antibodies. But a new study is out showing that T cells, if you've been vaccinated, you have the coverage. The vaccines are allowing coverage from alpha to Omicron. All of them, the T cells recognize and respond to. So at this point in time, that does explain why there is less severe disease with Omicron than there has been previously, especially as more and more people have been infected through time. So it's very exciting in that respect. And then additionally, there's been some recent work looking at predictors of long COVID, and a new study has been published in Cell that reports a number of predictors for individuals who will potentially come down with long COVID. And so it is great in one way because it's going to make it easier to predict long COVID occurrence and potentially offset that long COVID occurrence. Some of the things that they've been looking at there is the reactivation of latent viruses during initial infection, and the things that we're thinking what we're talking about in that respect are like Epstein-Barr virus, viremia. There's also issues with people who have type 2 diabetes. If there are high levels of SARS-CoV-2 RNA antibodies, if there's lots of high levels of the virus and antibodies in the blood at the time of diagnosis, that is also very likely to lead to um, long COVID. So this more severe disease early on, and I'm going to sneeze. Whee, that was exciting. It's all me down here sneezing in my basement. Science, it makes me sneeze. Woohoo! Other things that are related are specific autoantibodies that they can measure for. So um, the detectability is important. It may lead to, like I said, the understanding of the emergence of more chronic conditions after COVID infection, um, and maybe treatments before that does set in. JG, you're saying you want to get more boosters. Well, if you've had your normal shot, had one booster, um, unless you are immunocompromised, it is not recommended that you get another booster shot. That isn't recommended at this point in time. They probably will be releasing that kind of thing in about 6 to 12 months. Oh, Kai just lost another tooth, everybody.
Yay, I've lost 4 teeth in the past year.
Woohoo! That's science. That is the most gruesome human biology.
Yeah. It
It's gruesome.
was actually kind of painful. I bled a lot.
Yeah. Okay. Did you pull it out?
Yeah, I was messing around with it. I just twisted it out.
Congratulations.
Yeah, but
Tooth Fairy's coming tonight.
But there was a huge cut, so I just started bleeding like crazy.
Uh-oh.
It's okay now.
Seriously, teeth are gruesome. Like they're like, like they push out. Like honestly, it is to me one of I love it. I love it. But it is one of the most gruesome processes that we have in our development as human beings. That's right. Take that, teeth. Woohoo. He's getting into the adult teeth here. It's very exciting. My baby's growing up. Oh my goodness. Oh my goodness. Beej, yes, your comment, the whole thing about the virus is it is adept at evading our immune systems from the very beginning. And that's true. It's also the way that the actual cellular infection happens. There are a couple of mechanisms by which SARS-CoV-2 accesses the cells. And the difference between the alpha through delta, which affect the lungs a lot more, and why we have had much more respiratory symptoms and disease from from those variants of SARS-CoV-2 infection than Omicron, is that Omicron actually the way that it infects the cells might make it less able to cause the disease in the lungs, and so that's why we're seeing more sinus and throat kind of symptoms coming through. But yes, COVID. Their researchers are learning, and like I said last week, we don't know where it's going to end. We don't know what is going to happen in the long run, as we shift from the pandemic to endemic. But remember that diseases like malaria are considered endemic in other areas of the world. So endemicity does not mean not dangerous. And that is something that we just do need to consider as we look forward into the future of living with COVID. Right, JG? No one cheers when we lose teeth anymore. It's like, can I go back to the dentist and put this back in again? An additional note that I thought was, oh, I totally lost that train of thought. You know, when you're standing here with a microphone all by yourself and you have things to say and then they go away and there's nobody to save you. That does happen. It totally happens. And so that was a thought that went away. Yeah, Kevin. I think many of us have forgotten what normal was. And in fact, it's good to not go back to normal because normal is what got us this pandemic. And if we go back to normal, it's very likely that it will lead to more pandemics that are hopefully, would likely be as devastating as this one has been, maybe even more. So can we move forward to a new normal in which we live sustainably and are able to develop a public health system that works in a way to prevent future pandemics from affecting us as much? I mean, that's what you hope. Can we learn from our mistakes? Huh, humans? Learning is good. Learning. We like the learnings. Yes. Oh my, oh my. This is This Week in Science. Thank you so much for joining me for this episode. If you enjoy the show every week, maybe consider supporting us as a Patreon donor. If you head over to twist.org, you can click on the Patreon link, and that takes you to our little community over on Patreon, where you can choose your level of support. $10 and more will get you thanked by name at the end of the show. We have lots of other thank yous, and there are gifts that are sent out by Patreon periodically. We do hope that the gift of TWIS is enough for you, though. Thank you for your support. We really can't do this without you. All right. I only have a few more stories here. And as I sit here and drink my water, I'm not thinking about a glass of wine after this show is over. I'm not thinking about a beer or whiskey. One whiskey. Wait, how does that? That song, I lost it. A whiskey, something, and a beer. I've totally lost it. Anyway, researchers have been trying to figure out how to get people to drink less alcohol, especially people who have problems with alcoholism. How do you reduce the cravings? How do you reduce alcohol consumption? And of course, they've done many, many experiments in mice. But what can we do in people? That's the fun one, right? Well, they still haven't done anything in people along these lines. Monkeys. Monkeys will definitely do the trick. Let's use monkeys. So, researchers published just yesterday in Cell Metabolism their study looking at vervet monkeys that had a strong preference for ethanol. The little alcoholic monkeys. There we go. Um, and research had suggested for years that a particular hormone related to fibroblast growth factor. And there's a particular factor that's produced by the liver. There's a number of them that are produced, but this one particular growth factor, fibroblast growth factor 21, FGF21 specifically, has been implicated in control of metabolism, control of weight gain, weight loss, muscle wasting or atrophy, and also craving for protein in your diet or avoidance of sugars. And so this is over the years been it's been a hormone of interest, and they know that it affects the brain. They know it affects the dopaminergic system. They know it affects the nucleus accumbens, which is part of the brain that's in the reward pathway involved in sugar cravings and all that kind of stuff. And so these researchers were like, okay, we know that we have some of these pathways in the mice. We have done this work, and we know that if we give them FGF21, it reduces alcohol cravings in mice. Is it going to work the same in the monkeys? Because, if it works in monkeys, it's much more likely to work in people. So they gave these vervet monkeys FGF21, and dun, 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 the monkeys consumed 50% less alcohol. They reduced their alcohol intake. Now, what I want to know that they did not look at, they didn't look at any other dietary factors, but since FGF21 mediated suppression of sugar intake usually happens with an increase in intake of protein. I wonder if, like, these monkeys were like, "I'll have the steak and eggs breakfast, please. Please." I don't know if that's what they were, if they wanted to increase their protein intake at all. But this is a hormone, a factor that is produced by your liver naturally. If you are not eating enough protein, FGF21 gets produced by the liver, and the liver goes, "Dudes, I don't like this. You need to eat more protein." And it kickstarts a pathway to get you consuming more protein so that you have less muscle wasting. It's also, and there's some interesting relationships they've found between like ketogenic diets and fasting, and so it is very dietarily related. But in this particular case, they were able to show that it triggered suppressive neural circuits within the brain that led to suppression of activity in the nucleus accumbens, so suppression of that reward pathway. And so FGF21 potentially is something that can be used to reduce alcohol alcohol intake in people who would like to reduce their cravings a bit. But we haven't done any work in people unless we want to consider ourselves monkeys. We're not monkeys. We're not monkeys at all. We're related, but there needs to be more research before you start looking for those FGF21 supplements. And I already did a search and there aren't any really. You can buy like lab grade FGF21, so just don't even go looking. Gaurav Sharma, hamsters. Some hamsters have a high alcohol capacity, probably genetically determined, and depending on their livers. I mean, livers are the organs that help to clean the blood and to detoxify with the alcohol dehydrogenase and all the other stuff, the good stuff that goes on in the liver to clean up your blood. And I'm guessing that they probably have a similar system involving FGF21 because this is a very conserved hormonal system involved in dietary intake. And it's not necessarily alcohol intake, but we do know that animals throughout history, if we became introduced to alcohol with fermenting fruits, probably somewhere way back in our family history, our evolutionary history. So, where we came from, where did we come from? We were eating little berries on the trees, and some of the little berries were fermented, and suddenly, oh, we're drinking alcohol sugars as opposed to just eating sugar. And our body had to deal with some of that, but it probably is linked in a similar pathway to control it. Yeah, and JG, yeah, I mean, FGF21 or less impending doom. That would work as well. Oh my goodness. Oh, okay, let's move from FGF21 suppressing. Oh, I had a whole picture as well. I keep forgetting it's me by myself, and so I keep forgetting to show off pretty pictures that we've got. Oh, that's a very tiny picture right there. Boop, there we go. Let's make him bigger. There, you can see the liver and the FGF21 and the mice and the monkeys having beverages because somebody thought that would be funny. Enjoy the wine. Yes. Yes. But anyway, it's pretty interesting that we have these hormonal pathways from our liver to our brain that control what we want to put in our bodies, right? So that's a very fascinating process. It's all connected in there deeply. Okay, moving on. Two more stories. We don't want to talk about balanced diets. We want to talk about a mashup of our vision. Oh, yeah. So this story, I think, is super fun. And what I enjoy about it is the research that the scientists have embarked on. So these scientists Let's see if I can get my video up here working the way. I have to open up a different window so that I don't show you all the advertisements. I don't want to show you advertisements. I would have had more time to set this up if I had co-hosts. So this is hopefully a part of the podcast that gets cut out. Okay, here we go. We're going to look at this wonderful video, visual instability here. Researchers who have just published their work are interested in how our brain gives us visual stability. So, we move around, and if you've ever tried to like take a video with your phone as you're walking and moving really quickly, you can see the way that things blur past, and your camera potentially has a hard time keeping up with the images that move past you as you move. How does our brain stabilize perception within our visual field? So, these researchers in this particular video, they're giving an example of how our visual field moves around. If you're looking through, say, a little tiny hole and trying to track your world through a little tiny straw, you're going to just be getting snapshots and very incoherent, unstable representations of the world around you, as opposed to the much larger. Whoop, this is now sending me I'm learning about object-oriented programming in Python. No, we're not going to do that right now. We're going to do something else. And so what they tested, they gave volunteers videos of time tracking the aging of an individual. So one side of the screen showed an individual aging over time, and the other side showed the individual just staying the same age. So they, through artificial intelligence, artificially aged a person over time. And when they asked people to let them know how old the person on the left side of the visual field was, everybody estimated the age as the age not where the video ended, but at a point prior to the end of the video. And so what they're hypothesizing is that our brain is pretty much procrastinating in how it tracks the world, and that our perception of the world is actually about 15 seconds behind what's actually going on, and it's a mashup that our brain has pretty much taken, like, all these bits and pieces, and mostly it liked the first instance, the first perspective it got, and it's like, "Oh, that's great, we're gonna keep an eye on that." And so, this is why it's so easy for something to change in your visual field and you didn't miss it entirely. Why we succumb to visual tricks so often is that our brain is like, "No, we're just gonna I like all these things, and we're gonna dither." So if you're if you understand the idea of digital dithering, that is what our brain is doing. It is taking all the snapshots of, even if you're just looking, not moving, and just looking at the scene around you for a minute or so, your brain is taking constant pictures. But it doesn't need. Your brain's like, "I'm lazy, nothing's changing. Why do I have to pay attention?" And so it doesn't. And it gets lazy, and it just goes, "Okay, we're gonna cut, and we're gonna put it together here. We're gonna mash that together. That's the same. Oh, that's the same." And then your perception is not actually keeping up with reality. So we're behind because our brains are lazy, which is, I think, it's just hilarious. Really? My brain, I want my brain to be on it. Why is my brain not on it? Why is your brain not on it? Well, because our brains like to conserve energy any way they can. Let me see if I can find this video for you of the faces so that those of you who are watching the video right now will be able to kind of track this yourself and let me know what you think of it. People on the podcast, this won't really make sense for. Let me get this. Move that over. I'll put this over here. There we go. Okay. Adding it to the stream. Okay. So the images, you've got the image on the left and the image on the right. They're two identical twins. They're the same age. Okay. How old is the person on the left? You just make your judgment. And you're just going to watch that face. Just watch that face. Keep watching it. Keep watching the face. It's watching you. Are you watching it? Watch the face. How old is the person? How old is the person? How old is the person? Do you know? So you might not have really perceived that much of a difference, but the face on the left aged by a little over 10 years from the original time. And now they're going to show it again with an age counter. So from the original age, now it's a year older, year and a half, 2 years, 2.5 years, 3 years older, 3.5 years older, 4 years older, 4.5. And so your brain doesn't keep up with this movement of the aging and the change in the little features. Your brain is like, man, okay, general gestalt, that's good. And our perception likes to stabilize our chaos by biasing towards the past and what it knows to be more true or more reliable. It's pretty fun, right? It's a neat little trick. So how old was the face when it started and when it ended? Let me see from this story. Did they report it in the story? I think it was they just reported it being a number of years older, but I think it was probably like 7 or 6 or 7, and then probably like under 20. It's not old at all in the video. It's very young, very young. All right. My last story for the night is one that's kind of close to my heart because, I mean, I want to age gracefully, as hopefully many of us would like to try to do. And as you get older, and for those of you who are young and watching this, yeah, you've probably noticed the people who are older in your life complaining about aches and pains a little bit more as they get older. Maybe you too are starting to, my aching back. Ow. You wake up in the morning and you groan a little bit more at the pain. You wake up with random pains you didn't have when you went to sleep the night before. Researchers from the University of Portsmouth have done a study in which they examined 5,800 people age 50 or more, and they looked at them over 10 years. And over the 10 years, they wanted to determine how many of them, deteriorated in their physical state. How many started complaining more of pain, how many had chronic pain, how many were dealing with it, and what were the differences, what potentially made the difference in people who suffered from musculoskeletal pain as they aged at the end of the 10-year period. And what they found is that the people who worked out really hard are the ones who had the least aches and pains at the end of the 10-year period. So they examined the experience of chronic pain alongside gender, BMI, age, and wealth over this 10-year period. And it's high levels of physical activity that appeared to lower the risk of that musculoskeletal pain developing. Risk factors, definitely. And, we've talked about social factors that are involved in this kind of thing in the past, being poor, being female, being overweight or obese. all independently are risk factors for suffering for musculoskeletal pain, according to their study. And we probably could have told her that. But they think from their study that their findings suggest if people want to avoid chronic pain, yeah, become wealthy. Don't be female. No, these are not the things that that they're suggesting, but it's not even just moderate exercise. And we talk about exercise levels, oh, it's just going for a walk, or yeah, you're exercising when you're vacuuming the house or doing dishes, you're standing up, you're not just sitting down, right? No, moderate exercises like light dancing, walking, stretching, gardening, these kinds of things were not even able to keep the pain away. It was high energy, vigorous physical activity that led to the differences. Yeah, so the idea is that it's not even just mild exercise. It's heavier exercise that you have to do, intense exercise to avoid the pain. So if you want to avoid the pain, go running, play tennis, tackle football. Wait, no, maybe not the tackle football. Soccer, do the headers. Maybe not that. I don't know. But more intense, probably not so intense that you are injuring yourself, but more intense exercise is probably better. And I'll say from my own experiences with back pain that the more I actually do work out and do exercises that support my musculoskeletal system, the better it makes me feel, and the less pain aside from the workout pain I have. I wake up with fewer aches and pains. Yeah. Oh, yes, we have dark humor. I have dark humor as well. Dark humor, everyone. And yes, yes, Ashley, you'll be golden as you age. Yeah, pain from minor injuries, not from sedentary lifestyle. Oh my goodness. I made it. I did it. Came to the end of the show with all of you, and you stuck with me, and I really appreciate you being here for the science this week. And I want to thank all of you for enjoying the science, bringing your commentary, being a part of the TWIS family. Thank you for joining me once again. And for everyone out there, I guess it's time for me to say goodnight. Maybe I'll do a little bit of an after show with and talk with you all in the chat room about little things. We missed Blair and Justin this week, but they hopefully will be back next week. Justin, I'm guessing he's not going to be back right away because he has a newborn child. So we're not promising on that one. We'll see. I need backup plans for my backup plans moving forward. I hope you all enjoyed the show. Shout outs to Fada. Thank you for your help with social media and show notes. Gord, thank you for manning the chat room. Identity 4, thanks for recording the show this week. Rachel, thank you for your editing and your assistance. And I would also really, really like to thank our Patreon sponsors, who I need to put in the proper place, because this is always what I do at the end of the show, is not have everything located in the right place for actually showing the list. Here it is. Woohoo! Thank you to Richard Badge, Kent Northcote, Rick Loveman, Pierre Velazar, Ralphie Figueroa, John Ratnaswamy, Carl Kornfeld, Karen Tazi, Woody M.S., Andre Bassett, Chris Wozniak, Dave Bunn, Begard Chefstad, Hal Snyder, Jonathan Stiles, a.k.a. Don Stylo, John Lee, Ali Coffin, Maddie Perrin, Gaurav Sharma, Don Mundus, Stephen Alberon, Daryl Myshak, Stu Pollock, Andrew Swanson, Fredus104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, Matt Bass, Sean and Nina Lamb, John McKee, Greg Riley, Mark Hessenflode, Gene Tellier, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Dana Pearson, Richard, Brendan Minish, Johnny Grindley, Kevin Railsback, Rami Day, Flying Out, Christopher Dreyer, Artyom, Greg Briggs, John Atwood, Hey, Arizona, Support Aaron Lieberman for governor. Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul Mallory Sutter, Philip Shane, Kurt Larson, Craig Landon, Mountain Sloths, Jim DePoe, Sarah Chavis, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, EO, Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie Ball Disney, David Simmerly, Patrick Pecoraro, Tony Steele, Ulysses Adkins, and Jason Roberts. Thank you all for your support of TWIS on Patreon. And if you would like to support TWIS on Patreon, head on over to twis.org and click on that Patreon link. On next week's show, hopefully the hosts will be back. We will have another show of This Week in Science for next week in science, and I do hope to see you then. Oh, we will be broadcasting from our YouTube, Facebook, Twitch, and twist.live.org is where you can find links to all those things. Want to listen to us as a podcast? Oh, yes, you do. If you're not subscribed, you can find This Week in Science wherever podcasts are found. And if you enjoyed the show, get your friends to subscribe too. For more information on anything you've heard here today, show notes and links to the stories will be available on our website, twist.org. And you can also sign up for our newsletter that may come out again someday. I have a newsletter too, personally, just me. I'm doing one now, so let me know. I'll put a link out somewhere so you can subscribe to my newsletter. For information on anything you've heard here today, show notes are going to be available and links to stories will be available on our website, twist.org. I already said that. You can contact us directly. Email me, Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, Blair at blairbaz@twist.org. Put TWIS in the subject line so your email doesn't get spam filtered into the hind gut of a capybara, where its wonderful, beautiful, amazing enzymatic activity will filter it into oblivion. You can also ping us on Twitter, where we are at TWIS Science. I'm at Dr. Kiki. We have at Jacksonfly and at Blair's Menagerie. We do love your feedback. So if there is a topic you'd like us to cover or address or a suggestion for an interview, please let us know. We'll be back again next week. And we do hope that you will join us for more great science news. And remember, if you learned anything from the show, remember, it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan.
Wah, 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 wah. Ooh, newsletter, yes, please. Yeah, I've been writing a newsletter. This is the after show. Thank you all so much for sticking with me for the show. Never mispronounced a name. I try, Tarun. I do try. See if I can get all of the words out. Okay. Good night, Kira. I hope you have a lovely night after enjoying your wine. Where is that link? I'll get you my link to my thing. What's this? Just saw this. Rising temperatures were causing some plants to flower almost a month earlier. Yeah, we've been recognizing stuff like this for a long time, and it's been shifting. First it was a week, and then it was 2 weeks, and now it's a month. And that kind of a shift can be really dangerous, not just because the plants are blooming earlier. You're like, "Oh, flowers earlier than normal. Why is that a big deal?" Um, when it happens, there becomes a potential disconnect between the pollinators and the flowers and the animals that all live in the ecosystem together. And so you have the potential for the ecosystem to fracture. And because of that fracturing, the time dependency being limited, you end up having problems with populations able to maintain themselves. You have animals who can't find food. You have like everything falls apart. Blah. Your avocado tree started blooming this week. You're up in Seattle. That is weird. That's weird. Paul, that is whoa, 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 wah, wee, wah, wah, wah. Yeah, and I mean, normally, in a normal shift, you see the plants moving slowly and the animals and the insects and everything tries to keep track as everything moves slowly together, as opposed to things going, "No, the sun changed, it's sunnier, it's warmer, I got a flower, and that's not gonna work anymore." Okay, I'm looking for my newsletter link. That's not it because I'm not spelling it correctly. Nope, because I can't type. I can type. Oh, you don't want to do it on here. Maybe I'll look over there. I have to sneeze again. Sniffles. See ya, Fada. Thank you. Indoor avocado. Okay, I can get that. I can understand that. So let's see. Not episode. Issue 4. How do I get this to share with others? Here for peoples to subscribe. Yes. Okay, here we go. Well, I'm just going to copy the whole thing, even though I know most of it is just tracking. There's a link. Okay. Get review. Yes. So I'm using Get Review for my newsletter. And I'm trying to do, it's my new, I will write practice, because if I create a writing practice, then perhaps I will be a writer, write something worthwhile. Yes. So I'm trying to publish this newsletter weekly, and so far, I've talked a bit about misinformation and trust and science. I share science stories that I don't necessarily share here on the show. And I have sometime, I think this last newsletter, I put in a recipe that I made up. And I also include movies that I'm watching and thoughts on movies. Rick Loveman wanting to know which streaming software I use. Are you asking me? I use it's a platform called StreamYard, and it is browser based entirely. So everything that's done is through the browser. I have no hardware other than my audio video just mixers that are here. Yes. So that's what I do. And StreamYard allows us to connect to YouTube and Facebook. And if I paid more money, I could add, other things. So we do our YouTube and Facebook and Twitch through here. Yeah, I like the StreamYard. This is good. This is very good. And it seems to be, it's been bought by, they were recently bought by an online event company that I'm blanking on right now, but the guys who built it are still in charge of it, and they seem really nice and I don't know. It's a good company so far. I'm still happy. Everything's good on my end over here. And just like the avocado tree, I have no idea what month it is either. How is it February? How is that even possible, everybody? When did that happen? How did we get here? Whee! My brain CPU needs an upgrade too, Shubru. I'm going back through some Discord comments there. Well, unless we have more science to discuss. Who wanted to know? Somebody had asked about, I think it was Eric Knapp, whether Blair had a cold. She actually has TMJ. She was diagnosed with TMJ, and apparently it's induced from holding her jaw in an odd way during while wearing a mask all day long. So yes, Gord, still February 2020. That's exactly it. Woo, 2020. It's gonna be great when we finally hit 2021. And I haven't aged the last 2 years. No. Yeah, but Blair has TMJ, and, she initially texted me, but I missed her text, and so she had to call me, and I felt bad afterwards because she's like, "I can't do the show because my jaw hurts so much, and I can't talk, and I don't know if I can spend 90 minutes doing the thing that makes me hurt." So, fingers crossed that she'll have gotten the inflammation down by next week and be getting things under control. TMJ, yes. Let's see the actual. Let's look. Oops. Okay, let's look up TMJ and how it. This is a learning moment, everyone. TMJ. Yeah, temporomandibular joint dysfunction. I want that to open. Come on. I want to see that picture. And it's interesting because I was complaining about my jaw popping the other day, and I've been wondering if mask wearing could actually impact this. And apparently, because you hold your jaw differently for whatever reason while the mask is on, it can impact your jaw and inflammation. And let's look at this one. The Mayo Clinic. I trust the Mayo Clinic for its images. Let's open that up. Share, share, share. TMJ disorders. Dun, dun, dun. Yeah, we're looking at this joint here where your lower jaw fits into your upper jaw, and you have the cartilage in there, and then you have the muscle. And so the nerves in that joint can become very inflamed. And the cushion, the cartilage can actually get worn down over time, which can cause like a permanent dysfunction, which can be no fun. But it's, yeah, all the stuff that's involved in jaw movement. And, as you're talking like this all the time, you can imagine that it would hurt a little bit. And so she took tonight off. But it was the last minute. Oh, that's great. Your dentist always checks from it. That's cool. Other symptoms from mask wearing. I know people also, if you're wearing a mask all day long, if you're not cleaning your masks, people can get have skin problems. You can get skin disorders, perioral dermatitis, and others can be aggravated because you're creating a little humid environment that is around your mouth on your skin that's great for bacterial growth and pH change and all that kind of stuff. So, yes, JG, I think your comment there is great. Switching up between different types of masks, switching between different masks, trying to switch. If you're wearing your mask for 8 hours a day, consider changing it a couple times a day if you can. I mean, there's all sorts of Yeah, all sorts of things. But, yeah, a CPAP full mask could cause that too, probably, for sure. Yep. But, yeah, it can be TMJ can be debilitating. It can lead to migraine headaches because of the inflammation of the nerves. You can also, it can aggravate or cause, tinnitus, which is the ringing in your ears, because those nerves are right next to your ear, so it can there are lots of things. Pain in your head is one of those things that is very hard to ignore. Sometimes you can be like, "Oh, my knee hurts." I can ignore that. But when you it's in your head, toothache, jaw ache, headache, like, yeah, no. I hope Blair went to bed and got is getting a good night's sleep. I hope that's what's going on. Yeah, cool. Savage Shield, I haven't seen that one. Yeah, I mean, there are all sorts of designs. I mean, the big thing is you wanna make sure, depending on the use and what you're doing, where you are, how many people are around, you wanna just have as close a fit as possible, N95, KN95 if you possibly can. Whether that is a single strap around the head, whether it's two straps around the head, whether it's around the ears, there are all sorts of designs. And I'm going to sneeze again. I think there's a bunch of dust down here in my basement. Like, I need to vacuum and dust, I guess. Whoosha, whoosha. I got to sneeze all over the place. Oh, Kevin, so you had it about 15 years ago. Yeah, it can really hurt. So I understand why Blair asked to take tonight off. Um, and she asked, she said, "Are you gonna do the show?" And it was like 6 o'clock at night when she called, and I was like, "Yes." The show must go on. The show must go on. I don't know. I might have been able to if I'd really scrambled been able to find a co-host, somebody to banter with, but, it was okay. It was alright just to be here with you tonight. Not as fun as the banter as normal, which I know that's a lot of what you all enjoy so much. Yeah, so Gaurav, yeah, questions about, annual shots, or, it's what people perceive as risk, right? What do they think their risk is gonna be for getting the flu? Even here in the United States, we have a very low annual, flu shot uptake. So, in the United States, we really don't have the kind of flu vaccine coverage that we wish we did, and because of that, there's a very low flu shot effectiveness over time. But because it changes every year and we've had a bit of, people maybe have had it in their life. And so you have the T cell response in addition to B cells, that works. But yeah, it's a big question, Gaurav. What are people going to do here in the US or elsewhere? Are they going to get the shot every year? I don't know. I have no idea. I have no idea. Oh, thanks, Eric. My one band, my my one Kiki band. Ah. Oh, yeah, Rick Loveman, yes, I've seen some of these Olympic Village stories, and I totally forgot to mention during the show that, yes, the Winter Olympics are ongoing in Beijing right now, and that's super fun. I can't wait to be able to actually sit down and take some time to watch some of the Olympic events. I do love, um, curling. Sweep the ice. Prepare the path. Sweep the ice. What's the other one? The luge? Yes, the luge. That's a good one. Winter sports are so much fun. So I can't wait to watch some, figure skating and other things and see what happens, even though it is completely an abnormal year, but at least It's happening. Yeah. And they've had to quarantine. People have had to quarantine for 2 weeks or so before actually getting in to compete. There's a lot going on. It's very neat. I want to check out some of the tech features that they're working on. That's a really interesting point. There's a lot. There's so much we could do. So much everyone can do. The Olympics. I don't know. Once upon a time, it was like the Olympics, and I was so excited about them, and it was bringing the world together. And and then you realize it's like, oh, well, there's all these politics around it, and I'm just gonna go back to my science. Let's just go back to the science. But now the science is like the politics, and it's all the everything. Yeah, you can't get away from it. People are people. Oh, Canadian Scotties women's curling tournament going on now. Well, how can I keep people from that? Why would I do such a thing? Oh, Gorov, you're right. I can kind of get around the politics for Eurovision because it's Eurovision. And I'm so excited. I love Eurovision. And the fact that it's coming, I can start getting excited about all the pre-contests and all the contestants and the songs that are going to come for this year. So, oh, you all are going to hear about Eurovision for the next couple of months. Little bits and bobs everywhere. Yeah. Yeah, Kira, I'm looking forward to all the Olympic events so much. I think it's just going to it'll be great. Like, yeah. We need, I don't know, we need these things that we do, these competitions, these moments of humanity. Um, and if you need something just, in addition to the Olympics that are going on, Cool Runnings is always just a fantastic movie to watch. It's a great movie. And bobsled. Jamaican bobsled team. So good. Yeah, highly recommend Cool Runnings. If you haven't seen it, or if you haven't seen it in a very long time. Oh, they already had all the curling. Kevin Parachan says that there's women's curling going on right now. Get into it. Yep, you can't get away from the politics. You're just in it. Yep, philosophy, politics. It's all about it. Beach, the movie is so great too. Like, it's really, really good. It's got a lot of heart, just like that team. Yeah. Okay. They really did earn that privilege for sure. And the fact that that's a true story it even makes it even more. It's not just a Hollywood movie. It's like this is it, and yes, it's dramatization and storytelling, but still it's a true story and it's really amazing. That's humanity. That's people. That's what we can do. And so, to find those moments where we're reminded about who we all are on this planet, right? We can do this. Let's make it forward together, everyone. Oh my goodness, Rick Loveman. From kitchen to table, visitors to the Olympic Village are served entirely by catering robots, which flip burgers, drop food right onto athletes' tables, and even do deliveries. I love robots. That's awesome. Just don't look them in the eyes. Don't look the robots in the eyes. It slows down your response time. So, just note for the future when you need that information. Yeah, based star. True story. Yeah, I would imagine no group dining. Yeah, that sounds like the kind of precaution that would make sense for the Olympic Village. Fingers crossed that they get through it with relatively few infections. I mean, Beijing has been so careful, but at the same time, blah, this Omicron's kind of crazy. But it is what it is. It is what it is. Yeah, Kevin, that's right. We don't need athletes. We just watch Robo Olympics. That's great. That's right. Well, my friend Dave used to run the Robot Olympics, Robo Games. And that was pretty fun. They'd had all the robot fighting, and they'd have robot soccer, and they had robot firefighters who had to go down obstacle courses and blow out a candle, and so much fun. It was so much fun. We need more of that in our lives. And then I know somebody else who is involved in running the US drone soccer. Um, yeah, that's a new thing. And I think it might be Navy sponsored. But this is like a crazy thing I hadn't even really considered before. This drone soccer, where they're taking these little drones and they have they're doing such cool stuff. Wait, why is that doing? Yes, there we go. There's my window. I don't want to launch the trailer on YouTube. We could be first in line to join the newest esport. These games, drone soccer in Colorado. Exciting. Let's fast forward. Oh, people have beards and microphones. That's exciting. Okay, so they have little, wow. Look at those things. Can you see those? Is that too small? The robot dogs from Boston Dynamics are so cool, Kira. And yes, Rick Loveman, it is the year of the tiger, and it is specifically the wood tiger, I think. And yes, the Puppy Bowl is coming up. That's true. That happens opposite the Super Bowl, I believe. So they've got drones like in a roll cage, and they're in like a little tiny arena, and they try and go through a goal. Interesting. It's like Quidditch. This drone soccer. It's like Quidditch, it looks like. Oh, there go the drones, and they're weaving and wending, and oh, they gotta go through the little goals, and I want it to be more action. Is that wrong? But that's pretty fun. Some of the new esports are incredible. US drone soccer. Newest E-League. Exciting. I know little drones living their Quidditch dreams. It's true. They're out there. Yeah. People are doing fun things in the world. I think we need more fun things. Puppy bowl and kitten bowl. Yes, there's a kitten bowl. People started doing a kitten bowl opposite the puppy bowl because of course we have to get kittens adopted as well. You got to get the puppies adopted. You have to get the kittens adopted. There's a lot of animals out there who need loving homes. They do. It's true. And there are a lot of young kids who need their little drones for playing soccer. I'm a tiger. I'm a year of the tiger. I'm a Leo born in the year of the tiger. I'm also a scientist. So I don't know what any of this means for me personally. This year is supposed to be as a year of the tiger. The tiger. There's also water involved, and the wood and the water, and there's supposed to be growth. So this year is supposed to be hard but full of growth for me personally. I don't know. I like to have growth every year. Status quo is kind of boring, right? Yeah. I want to try new things. Let's do new things, everyone. Yes! Cats and dogs living together. Puppy bowl and the kitten bowl. Ah, yes. Okay, friends. This is very enjoyable hanging out with you all right now. But I'm gonna go to bed. I'm gonna take puppy and kitten thoughts. I'm gonna go find my cat, actually. I don't know where Cappy is. She's somewhere. She looked at me accusingly when I came downstairs earlier because I was not going to bed. And I think she was very upset that I was not going to bed. And she sat at the top of the stairs and just looked at me with her little cat face. So I need to go take care of my kitten Cappy. All right, everybody. Thank you so much for joining me for this episode. I apologize that my co-hosts were not here tonight, but the show did go on. Thank you for joining. I hope you enjoyed the science and my one Kiki show banter. And hopefully we'll get Blair back again next week. And I do have some guests I'm trying to line up. So hopefully we'll get some guest interactions here in the next few weeks as well. Thank you. Thank you. Thank you. Have a wonderful night. Stay safe, stay well, and stay curious. We'll see you next week. Bye.